means internal resistance or friction is negligible. And we also assume this liquid to be incompressible. That is, density all over in every part of the liquid to be same, to be constant. So such fluid is called ideal fluid, and for theory purposes we assume the fluid which is flowing to be ideal one. With this assumption, we'll proceed further to study fluid dynamics in today's meet, that is on 22nd 21 of July. So this is article 2.5 on page 44. 44 page nikalo. We have started today with article 2.5. So fluids flow basically in two ways, following certain particular geometry. The nature of flow of fluid flowing is determined by physical quantity which is called critical velocity, denoted by letter Vc. If the velocity of flow of liquid is less than Vc, the flow is said to be streamline. It is also called laminar. This critical velocity is related with another physical quantity which is dimensionless pure number which is called Reynolds number. It is denoted by symbol R capital N small suffix. So what happens if the flow is streamlined? Value of this Rn is less than 2000. So first basic flow of fluid in motion is streamline or laminar flow. This flow is steady and has orderly pattern. But if the velocity we see is less than the velocity of motion of fluid in motion, then we get another type of flow which is called turbulent flow. This is the second type of flow of fluid motion. This turbulent flow destroys the steady nature. Particles become irregular and hence many times it is undesirable. Only fraction of energy is available for forward flow of the liquid. Most of the energy is wasted. Rest of the energy is wasted. And hence, being undesirable, To study the fluid when in motion, we always consider fluid flow to be streamlined. In turbulent flow, value of Reynolds number is greater than 3000. So when Rn lies between 2000 to 3000, there is a chance to change over of flow from streamline to turbulent, or sometimes from turbulent to streamline. So there is a chance to change the pattern of the flow. So hence onward, while studying fluid motion, we will assume the fluid flowing in streamline pattern. But what are the properties of turbulent flow? Sometimes it is desirable. Sometimes. For example, we observe turbulent flow of liquid in mechanism of washing machines or in kitchen mixers. That time this turbulent flow is desirable. But suppose if you want few mechanical flights like aircraft or high speed cars, that time due to turbulence, increase in resistance, turbulence is produced and it is that time undesirable, and hence these bodies are given streamlined or aerodynamic shapes. So in few cases this turbulent is desirable, but in few cases it is not desirable. So we will assume the flow to be streamlined for further discussion. So first discuss the characteristics of this streamlined flow. What is that streamline? The very first characteristics, the entire fluid, the whole mass of the fluid moving, here we can imagine to be divided into large number of thin layers parallel to each other. The whole mass moves forward in different parallel layers above each other. This is its first characteristics. Now the flow can occur on horizontal plane surface or through tubes. ट्यूब में भी हो सकता है और हॉरिजॉन्टल सरफेस पे भी फ्लो हो सकता है. दोनों बाजू फ्लो हो सकता है. वी एज्यूम द लिक्विड फ्लोइंग इन बोथ दीज केसेस let in forward direction, and this liquid is can be imagined to be divided into number of thin layers. All these layers move parallel to each other. What is the second property? These layers move with same velocities. ये हम लोग एज्यूम कर रहे हैं. अरे सेम वेलोसिटी कब रह सकती है? इसकी वेलोसिटी, ये लेयर की वेलोसिटी, ये लेयर की वेलोसिटी, ये लेयर की वेलोसिटी, ऑल velocities are equal. This is only possible if the fluid is ideal. There is no any internal agitation. So he sub layers can move with same velocity. That is, particles moving in any part of liquid, all particles have the same velocity. This is only applicable if the fluid is ideal one. ये भी ध्यान रखना है. The molecules from one layer cannot enter in the other layer. Molecules are confined in that particular layer, and all molecules flowing in that layer move in the direction same as that of flow of motion of fluid in that particular layer. This is its next property. We are studying characteristics only for ideal fluid. But in practice, we never get ideal fluid, and we have to do the cases for real fluid. तो रियल फ्लूइड में क्या होता है? इट इज विस्कस इन नेचर, नॉन विस्कस नहीं होता है. इंटरनल रेजिस्टेंस काउंट्स, देर इज नो एनी इंटरनल फ्रिक्शन, ऐसी केस नहीं आती है. So in practice, when we come across real fluids, the characteristics of streamline we have to modify a little. तो उस streamline में क्या होता है? We practically and experimentally it is proved different layers move with different velocities. Velocity सबकी same नहीं रहती है. Always certain opposition is offered by fluid to relative motion between the adjacent layers. Each successive layer, जो ऊपर का layer है ना, the layer at the base is assumed with solid surface is assumed to be at rest, and each successive layer, if you move up through the distance normally in the direction to the flow of liquid, each successive layer has a little higher velocity as compared to its inner adjacent. Its inner layer means what? If you consider the case of liquid moving on horizontal surface, then the layer at the bottom is assumed to be at rest, and when you go up normally away from the horizontal reference level, velocity gradually goes on increasing. If this is v, this is v minus dv, this will be v plus dv, and the layer at the top surface has maximum velocity v naught, and if this is less than critical, then the flow is streamlined. This is not the case if the fluid is moving in a tube. ट्यूब में क्या होता है? The layers in contact with both sides of the walls of the tube are assumed to be at rest, and when you move inside from both sides, the velocity gradually goes on increasing. So layer at the center has maximum velocity, and that time this streamline orderly is called laminar flow. ये ट्यूब में होता है. हॉरिजॉन्टल प्लेन सरफेस में अपर मोस्ट लेयर मैक्सिमम वेलोसिटी है, और इसमें बीच का लेयर हैज मैक्सिमम वेलोसिटी. व्हेन यू मूव अवे फ्रॉम सेंटर टुवर्ड्स द वॉल्स ऑफ द ट्यूब, then velocity gradually goes on decreasing on both sides. So this is the case of streamline flow when in case of real fluid के बारे में ऐसा होता है. Second point, velocity at given point at one particular point within the liquid remains constant. From particle to particle, velocity changes. Suppose we get a liquid any point A. So each and every point of this fluid crossing A, entering A has certain constant velocity, and it moves in one particular direction. So all particles of the fluid crossing point A have same velocity and in same direction. Velocity may change from point to point. यानी कि आप लोगों ने और एक point choose किया within liquid. Suppose C. Velocity at A is V1, at B is V2, at C is suppose V3. Like this. If the flow is like this. Flow ऐसा है. Then at each point velocity may change, but all particles entering B or arriving at B should possess same velocity v2 till it crosses point B. So at one particular point, velocity remains the same within the liquid. And hence, in such case, we are able to draw a path. हम लोग एक पाथ बना सकते हैं. दिस पाथ शुड बी इन द डायरेक्शन ऑफ फ्लो. देखो ये ए पॉइंट है, उसकी वेलोसिटी v1 है. ये बी पॉइंट है, इसकी वेलोसिटी एट दिस पॉइंट वेलोसिटी बी v2. सी पॉइंट है, लेट बी वेलोसिटी v3. So what happen? You can draw path. It may be straight or it may be curved. Parallel in direction to the velocities at each and every point within the liquid, and hence fluid has to follow this path, and this is called streamline. हम लोग ये स्ट्रीमलाइन फ्लो में निकाल सकते हैं. दिस मे बी पैरेलल टू ईच अदर, बट फ्लो ऑफ फ्लूइड in this layer should follow the same given streamline path for that particular layer. So we can draw streamlines. So these two streamlines should not intersect because at two different points velocities may have different direction and different magnitude. This is one more property of streamline flow. What is next property? Third line, we can draw streamline. Fourth क्या होता है? As you move up in direction normal to the flow of liquid when flows on horizontal surface or through tube, change in velocity is observed and we always get velocity gradient. It is given by symbol dv by dx, rate of change of velocity with respect to distance of the layer from certain reference layer, that is layer at the rest. This is called velocity gradient. So velocity gradient is observed in streamline flow for real liquid fluid. जो आइडियल फ्लूइड है ना, उसमें वेलोसिटी ग्रेडियंट की वैल्यू 0 लग रहती है बिकॉज ऑल लेयर्स फ्लो विथ सेम वेलोसिटी. पार्टिकल्स इन एनी सेक्शन ऑफ द फ्लूइड फ्लो आर हैविंग सेम वेलोसिटी. तो वेलोसिटी ग्रेडियंट आइडियल में नहीं दिखा देता, लेकिन रियल फ्लूइड में इट इज ऑलवेज देयर. And this velocity gradient, change in velocity, is due to internal friction because the fluid under consideration is not viscous. थोड़ा सेटिंग में मुझे प्रॉब्लम आ रहा है. Adjust. Hope you are all adjusting the things. So real liquid में वो velocity gradient 0 नहीं होता है because it is non-viscous. Internal friction, there is certain force opposing the relative motion between two adjacent layers, and this force is called viscous force. The property of fluid to oppose the motion between two adjacent layer is called viscosity. इसको ये प्रॉपर्टी को विस्कोसिटी बोलते हैं. और दिस अपोजिंग फोर्स फॉर द मोशन इज कॉल्ड विस्कस फोर्स और इट इज ऑल्सो कॉल्ड विस्कस ड्रैग. दिस आई एम स्विचिंग ओवर ऑन point 2.6.2, मैंने 2.6.2 चालू किया है. So the scientist Newton studied this, and he has given the law of viscosity. He experimentally and theoretically proved the viscous force between two layers offered by fluid in motion is proportional to velocity gradient and also proportional to area of layer. तो जो लेयर का एरिया है ना, उसके लिए एफ डायरेक्टली प्रोपोर्शनल है, एंड हेंस मैथमेटिकली न्यूटन्स लॉ ऑफ विस्कोसिटी वी कैन राइट some constant a into dv by dx. So this a is area of layer. It is not cross section area. ये जो लेयर का एरिया है ना पूरा ऊपर का, वो एरिया है. This constant of proportionality is called coefficient of viscosity, and we write viscous force on layer of area A is equal to eta A dv by dx. Eta is called coefficient of viscosity. The definition of eta is given on page number 46. 46 में देखो. It is viscous force per unit area per unit velocity gradient, and due to this viscous force always the motion is opposed between the two layers. In fact, we can observe this viscous force if you consider a spherical body, solid body, rigid